This tutorial is about variables and data types in Rust. Learning of this will enable us to write meaningful programs. We will start with the variables. A variable is a named storage that programs can manipulate. They are also identifiers used to refer to memory locations inside computer memory that can hold some value for us, which we may change during the execution of the program. Each variable in Rust is associated with a specific data type. The data type determines the size and layout of the variable in memory, the range of values that can be stored within that memory, and the set of operations that can be performed on the variable. Variables are created with the let keyword followed by the name of the variable which I want to hold some value. In this case, we have declared a variable x. We can assign some value to this variable. Let's say a value of 15. You may note that as soon as I write the value for the variable, there are some additional information that is being added in front to the variable x. This additional information is basically the data type of the variable. The Rust compilers needs this information and it will try to infer it from the value that we are assigning to the variable. For instance, if I change the value to, let's say, 15.0, then you may note that the type information has been changed accordingly. In some editors, you will be required to add this information manually. However, in VS Code, where we have installed the relevant extensions, this is automatically being taken care of. In case of Rust Playground environment, this information may not be automatically generated. We can change the data type information manually also. For instance, I will change the data type to date of F32 in this case. A print command can be used to print the values of this variable to the screen. Let us add a print statement for printing the value of the variable x to the screen. Let us execute to confirm. Before we move further, it is important to highlight that Rust is a statically typed language, which means that it must know the type of all the variables at compile time. The compiler will usually infer the types of variables based on the value assigned to the variable. Later on in the course, you may note that there are situations when the compiler may not be able to infer the types, and we will be therefore required to specify the types of variables manually. We will see that later on, but for now just remember that the compiler needs to know the data types of all the variables in advance. By default, all the variables in Rust are immutable. By immutable, we mean that we cannot change their value. For instance, if on the next line we have a statement which updates the value of the variable x, then the compiler will complain. You may note a red line indicating to us some possible error. It says, cannot assign twice to immutable variable. This is one of the many additions in Rust which encourages the programmers to write code in a way that is safer. If one part of our code operates on the assumption that a value will never change and another part of our code changes that value, then it's quite possible that the first part of the code won't do what it was designed to do, and it may not be safer to use the value anymore because its value has been changed or modified. In summary, if you designate a variable as immutable, then the rest will make sure that this assumption holds throughout your program for safer usage of the value. This does not mean that we cannot change a value of a variable at all. If you intend to really change a value of a variable, then you need to explicitly specify that the variable is immutable. This is done with the help of mut keyword. So let us say we want to specify the variable x as mutable, then we will add the keyword of mut before the name of the variable. You may note that the red line is no more there, which means that our code is now correct. Okay, before we go further, there are some rules with regards to naming a variable that we need to be aware of. There are at least 3 rules. The first rule is that the name of a variable can be composed of letters, digits, and underscore characters only. For instance, if we add a $sign in front of the variable x, then it will give an error message. This is because of the rule that the variable names can only contain letters, numbers, and underscores. The second rule is that the variable names must begin with either a letter or an underscore. It should not be starting with a digit. The third rule is that the upper and lowercase letters are distinct because Rust is case sensitive. So now if I write, let's say capital X equals to 10, then this will mean that the small x and capital X are different variables and not the same variable. In summary, the variable names should only contain letters, digits, and underscore, and should start with letter or underscore, and the variable names are case sensitive. The variables can also be directly defined from the result of some operation. For instance, I can declare a variable y as let y equals to 5 times 5. So the value of the multiplication operation in this case will be assigned to the variable y. That is it for the variables for now. We will now look at the data types. Every value in Rust is of a certain data type, which tells Rust what kind of data is being specified so it knows how to work with that data. The Rust data types are divided into two groups or types called scalar and compound. In this lecture, we will be exploring the scalar type. The compound types will be discussed later on in the course. A scalar type represents a single value such as a value of 13 or the value of 3.14 or a character such as C. Rust has 4 primary scalar types that are integers, floats, booleans, and characters. You may recognize these from other programming languages also. Let us first learn about the integer data type. An integer is a number without a fraction component. Simply put, the integer data type is used to represent numbers. Depending on whether the number is positive or negative, integers are further categorized as signed and unsigned. Signed integers can store both negative and positive values. Unsigned integers, on the other hand, can strictly store only positive values. The signed types are indicated by I and the unsigned types are indicated by U. Moreover, we have 4 types of signed integers, which are I8, I16, I32, and I64. In the same way, we have 4 types of unsigned integers, which are U8, U16, U32, and U64. Each of these types differ in the range of values they can represent. The I8 has the least range, while the I64 has the maximum range. In the same way, the U8 has the least, while the U64 has the maximum range of values. To know the maximum value a variable of type I8 can represent, we can use the constant of max, which is defined inside the standard library submodule of I8. Let us print the value inside a print statement. Let us execute now. It represents the maximum number of type I8. Please note that the std is the standard library which is included in all the programs by default, and then inside this module we have the definition of the I8 and the information regarding its maximum value. We will cover the modules and the Rust module system later on in the course, after which this syntax will become clear to us. The I16, I32, and I64 has greater range of values respectively. You may use the same max function to know the exact numbers that can be used to represent using these types. Just note that 8, 16, 32, and 64 are the bits that are used inside the memory to represent the variables of these types. In the very same way, we have the unsigned types along with their respective ranges, with the only difference is that they can only store positive values and not negative values. To know the unsigned maximum value that I can assign to a U8 variable, I will use the same syntax as in the above case and will execute to see the maximum value. The types U16, U32, and U64 has increasing range of values respectively. We will now move to the second scalar data type, that is floats. The floating types can store numbers with decimal points. There are 2 floating types, namely F32 and F64. Let us declare a floating number z equals to 3.65. You may note that an F64 has been automatically assigned to this variable. This is the default type for a float variable. Again, the variable of type F32 has smaller range of values that it can represent, while the F64 has a greater range of values. Mathematical operations on variables with different data types are not allowed in Rust. For instance, the statement a equals to x plus z, giving us a compile time error with a message of cannot add a float to an integer. To force the operation to complete, we will need to change the type of one of these two variables. We will see that later on. For now, we will comment this out. As in the previous case, we can print the maximum value for a variable of type f32 by printing the value of max constant defined in the submodule of f32 inside the standard library. Let us execute. This is quite a large number and in practice will serve our programming needs. The next scalar data type is that of bool or boolean. A boolean type in Rust has two possible values, that is true and false, and is specified with the keyword of bool. Let us create a bool variable called status and set its value to false. Let us now print all the variables together. To enable printing of all the variables together, we will enclose it inside smooth brackets, and in place of the placeholder, we will write colon question mark. The colon question mark is used to display complex types of data that are not simple scalar values. In this case, although the individual values are scalars, but we are displaying them as a single unit, therefore the compiler may assume them to be of some other user-defined complex type. Therefore, we need to use the colon question mark syntax. The Boolean variables are useful inside a program to check for conditions being true or false. For instance, if I want to check if the number 18 is not equal to 18, then I will write something like this. The exclamation mark is used to represent logical not or logical negation. This statement means now that check if 18 is not equals to 18, and if found true, then assign true to the variable not underscore equals, and if found false, assign a value of false to the variable not underscore equals. In this case, it will have a value of false because 18 is equals to 18. Let us print the value using a print statement and execute. The operations such as greater than, less than or equal to, or greater than or equal to can be used in connection with the Boolean variables to check for different conditions. For instance, I can write something like 18 greater than 18 or 18 less than 18 instead of the condition of not equals to. In general, they are used to check for some conditions being true or false and are quite handy in programming. The last data type we will study is that of characters or char. The character can represent a single letter, digit, emoji, or Unicode scalar values or special characters. The values of characters are always enclosed in single quotes. Let me define some character variables. Let us print them all using a print statement and see their respective values. A note of caution with respect to the characters is that when we represent digits as char, then we are not allowed to perform the arithmetic operations on them, since they are chars and not integers or floats. We end this lecture here. In the upcoming tutorial, we will be covering slightly advanced topics related to variables called shadowing and the use of constants. That will be fun and exciting, so do come back for that, and until next tutorial, enjoy Rust programming.